Hello everyone and welcome back to another problem of the day, and today's problem is titled Form a Palindrome. So in this problem you are given a string and you have to find minimum number of characters to be inserted to convert it to a palindrome. For example, for the given string AB, you can insert either B at the beginning or A at the end to convert it to a palindrome, and the minimum insertion becomes 1 over here. Similarly, for the string ABCD, you can insert 3 such characters such that on inserting, the resultant character becomes a palindrome. So let's have a look at the naive approach which involves recursion. Let's take in the example A, B, C, D. So the basic logic behind finding if a string is palindrome or not is to check the first and the last character. So on checking A with D, I find that both of them are not equal. So I'll recursively call them for the right part of A, that is BCD, and similarly for the left part of D, that is ABC. So let's say I write ABC over here. Let me erase the brackets. Yeah, I'll write ABC over here and BCD over here. Alright, now this is done. I'll similarly check for ABC. So A and C are not equal. I'll call AB over here, BC over here. Similarly for BCD, I'll call BC over here and CD over here. And again recursively call AB. So A would be here and B would be here, B would be here, C here, B again here, C, C and D. Now since this is a single character, simply return 0. And again this is single, I'll return 0. And on receiving these two zeros, what I can do for this particular parent is that compare the two zeros, take in the minimum and add 1. So the minimum here is 0, I'll add 1. That would give me the result for this parent to be 1. Similarly for this particular part, it would be 1. And on receiving these two ones, this particular parent will take in the minimum of these two ones, that is 1 itself, and add 1. So I'll receive the value 2 for the parent ABC. Similarly, if I do the same operation on the right subpart, then I'll have 2 over here. And on receiving these two 2's, the parent will check the minimum of these two values, that is a minimum of 2 comma 2. Since it is the same, I'll take in 2, add 1, that would give me 3. So this is nothing but the result of minimum operation that I need to perform. But if you look closely, there are for this example two subproblems that are being repeated, that is B and C. But if you had, let's say, a string of size 8 or 9, then that may grow exponentially. And in order to avoid that, we have to use dynamic programming. So how are we going to use dynamic programming? So for this, we'll be making use of a variation of longest common subsequence. So for that, let's consider a string A, B, C, D, and let's consider another string B. Let it have the value F, B, C, G. So in longest common subsequence, you find the longest common subsequence which have the same character in the order for both the strings A and B. So for the consider example, B and C here have the same order, thus their longest common subsequence value is nothing but 2. So how is this going to help me solve the problem of finding minimum insertions? So for that, what I can do is, let's consider the same example A, B, C, D, and let's take in the reverse of this string A, which is nothing but D, C, B and A. Now if this reverse string were equal to A, then the LCS value would be the length of the string, that is 4 in this case. So if they had the longest common subsequence as 4, it would mean that both the strings are equal. So for the considered example, only one character at a time is like the longest common subsequence. For example, if I consider A, then only A here is the longest common subsequence. If we consider B, then only B alone is the longest common subsequence. C, then only C is the longest common. Similarly, if we consider D, then only one of the characters is the longest common subsequence. So for the considered example, the LCS value here would be 1. This means only one character is in the same order as the palindrome, and remaining 4 minus 1 uh, characters are out of order, meaning we would have to perform three insertions, or three, we have to place three such characters to make it a palindrome. So in this way we are going to solve the problem. So let's form using dynamic programming. What we'll do is we'll first take in the string A. Let's take in the same example A, B, C, D. We'll have the reverse of the string, let's call it R. We'll have the reverse as D, C, B, and A. And I'll place in all the 0th column and 0 row values to have zeros. And I'll make use of a matrix of size n plus 1 times n plus 1 to store all the recurring subproblems. I mean to store the values of all the recurring subproblems. And using this, we'll find the longest common subsequence. So we'll compare D with A. Since they are not equal, I'll take in the maximum value of these two, which is nothing but 0 here. I'll again compare D with B, take the maximum value, which is 0. Compare D with C, take the maximum value of these two, call it 0. Take it, compare D with D again. Since they are equal, I'll take in this value, add it with 1, and place 1 over here. Similarly, I'll do for C, compare with A, not equal, take the maximum, place 0. Compare with B, not equal, take the maximum of these two values, place 0. Compare with C, since they are equal, I'll call in plus 1 for this particular cell and add 1 and place 1 over here. Compare C with D, take the maximum of these two values, which is nothing but 1. Similarly for B, it would be 0 here. Since B and B are equal, I'll place plus 1 over here, 0 plus 1, that is nothing but 1. Compare B with C, not equal, take the maximum of these two, it would be 1. Compare B and D, take the maximum of these two, place 1. Similarly for A, since A and A are equal, I'll add plus 1, add 1 over here, compare these two, not equal, take the maximum, place 1. A and C not equal, take the maximum, place 1. Again, A and D are not equal, take the maximum of these two values, place 1. So this is my result. So the longest common subsequence for the considered string A and R is 1. And subtracting that value with 4, which is the nothing but the length of the string, I get the minimum insertions. That is the value of our, that is the result. So let's jump right onto the code. So first I'll create a variable, let's call it n, which will hold the length of my string. I'll have another string r, which I'll be storing using to store the reverse of the string s. So I'll reverse that string. I'll create a matrix, let's call it dp, of size n plus 1, n plus 1. Then let's loop over that matrix for int I equal to 0, I less than equal to n, I plus plus, for int I equal to, not I, j equal to 0, j less than equal to n, j plus plus. Alright. I guess that's fine. So first off, we'll check if the I value is 0 or the j value is 0. Since if that is the case, then we'll simply store our dp of ij value to have 0. Then we'll be checking if uh, if the string that we are on currently, that is s of I minus 1, if it's equal to the reverse of j minus 1. And if that is the case, then I'll store the dp value, that is I j, to have the value dp of I minus 1 j minus 1 plus 1. And if that is not the case, That means the two considered characters are unequal. Then I'll simply store the maximum value, which stores the dp of ij value. You have the max value between dp of r minus 1 j and dp of I j minus 1. And for the final result, let me correct the, alright. So the final result, I'll be returning n minus dp of n comma n. So let's try and compile. Alright, got a typo, I guess. Where are we wrong? Oh, alright. Let's try and submit. Alright, so that was it for today's video. If you have any doubts or suggestions, you can put them in the comment section. And thank you for watching.